This question is related to internal resistance. A torch battery having an EMF electromotive force of 1.5. So there's a torch battery which is having EMF, the maximum voltage it can supply is 1.5. When it is connected to a torch bulb, so it is connected to a torch bulb, the potential across dimension when connected to a torch bulb, the potential across or potential difference is 1.2. So the potential difference here across the bulb is 1.2. The total EMF is equals to 1.5. So what happened to the remaining voltage? That remaining voltage is actually drop across the internal resistance. So if total is 1.5, out of 1.5, 1.2 is across the lab. So remaining 0.3 volts will be there across the internal resistance. The current in the circuit is 280 milliamps. So we have to convert into ampere. So the current which flow, that is 280 milliamps. So it will be 280 into 10 to the power minus 3 ampere. Calculate the internal resistance. So formula which we can use, the total EMF is equals to voltage drop internally, which is given by I in small r, plus voltage drop externally, which is equals to I in capital R, or we can also say V. So total EMF, that is 1.5. The current in the circuit, that is 280 milliampere. So 280 exponent minus 3 multiplied by R plus the voltage, external voltage is 1.2. This will move other side. So it will be 1.5 minus 1.2 is equals to 280 into 10 to the power minus 3 into R. This 280 exponent minus 3 is multiplied, other side it will be divided. So it will be 1.5 minus 1.2 divided by 280 into 10 to the power minus 3. So this will give us the value of internal resistance, which is about 1.07 ohm. So the value of the internal resistance is 1.07 ohm. Then calculate the power transferred by the torch. Calculate the power transferred by the torch bulb. So we have to calculate how much power is transferred by the torch bulb. So we have the formula P equals VI. So power is a product of voltage and current. So torch bulb, the voltage across the torch bulb, that is 1.2. And the current which is passing through, because that is 280 milliamps, or we can say 280 into 10 to the power minus 3 ampere. When we multiply voltage with current, so it will be 0.336 watts. So that is the power which is transferred by the torch bulb. And if the same question was there, like how much power is dissipated in the internal resistance, so we'll take the voltage across the internal resistance, which is 0.3, and the total current, which is 280 into 10 to the power minus 3 ampere, will multiply. We'll know how much power dissipated in the internal resistance.